Fourth grade lesson 7.4 is subtract using models. So it's similar to the last lesson, but now we're subtracting instead of adding. Our essential question is, how can you subtract fractions with like denominators using models? Let's unlock the problem. A rover, this guy little here, needs to travel 5/8 of a mile, so not a full mile. If you cut the mile into 8 equal pieces, 5 out of those 8 to reach its destination. It has already traveled 3/8 of a mile. So if you cut that mile into 8 equal pieces, it's already covered 3 of those 5 that it needs. So how much further does it need to travel? How much further does the rover need to travel? We'll compare the fractions to find the difference. Difference, of course, by now you're recognizing, ooh, that's a subtract word. And then step 1 says, let's shade the model. We're shading the model to show the total distance that it needs to do to reach its destination. So I'm going to shade that in blue. Remember here we're between 0 and 1 full. 8/8 is 1 full. Zoomed in on the number line, 0, 1. If our number line continued, 2. Fractions are all those in-between numbers, the in-betweeners between 0 and 1. And we're going to shade into 5. 1, 2, 3, 4, 5/8 is how much it needs to go to get to its destination. So not a full mile, just shy of it, closer to half a mile, right? And it has traveled 3/8 of it already. 3/8 already traveled. I'll do that in red. 1, 2, 3 already traveled. And so what is the difference? How much more does it need? It needs these 2/8 left to travel, 2 out of the 8. We can write it as the difference, 5/8, 5 out of the 8 cut pieces. Subtract the 3/8 that we've already traveled is going to get us 2/8. So the rover needs to travel 2/8 of a mile further. That is the answer, 2/8 of the mile further. Now, I mentioned earlier in the previous chapter, you'll probably have to reduce that later. This is divisible by 2, and this is divisible by 2. I'm going to divide both of these by 2 to reduce it to its simplest form. 2 divided by 2 is 1. 8 divided by 2 is 4. So that is also known as 1/4 of a mile, 1/4 of a mile. How does this model show how far the rover needs to travel? Well, we could see that 5/8 was what it needed there. And since he had already gone past the 3, we could see there's 2/8 left. So it just showed us that there were 2/8 that still needed to go. So there's my answer there. It just shows that 2/8 is still needed to go. I can see it there. And explain how you can use the model to find 6/8 minus 2/8. Well, I could shade in 1, 2, 3, 4, 5, 6/8. And then take 2/8 away. And I would see that I need 1, 2, 3. Well, I'm going to put the 2/8 out of here. There we go. And now I can see I need 1, 2, 3, 4/8. So I can color 6/8 and then color 2/8 and see how much is left. Let's look at this Inplay a little bit more. Sam ordered a small pizza, I hope it was pepperoni, which was cut into 6 equal slices, 1, 2, 3, 4, 5, 6. He ate 2/6 of the pizza and put the rest away for later. How much of the pizza did he put away for later? So we started with 1 whole, which is also known as which fraction? Right, 6/6. So I'm just going to write that under there. And he ate 2/6. So we're taking the 2/6 he ate out of it. What's left is what he put away for later. So we could use a picture, shade 1 whole, okay, or 6 out of the 6. 1 whole is also known as 6 out of the 6. There, it's all shaded. Then we can cross out the parts that Sam ate. He ate 2 of the 6, so not that one and not that one. So those are gone now. He ate those 2. How much is left that he's going to put away? How many 6 parts are left? 1, 2, 3, 4 of them are left. 4 out of the 6. So Sam put 4/6 of the pizza away for later. And of course, if your teacher wants you to simplify that fraction, this is even, so 2 divides evenly into that. This is even, so 2 divides evenly into that. 4 divided by 2 is 2, and 6 divided by 2 is 3, so there is the simplified version. He put 2/3 of the pizza away. Visually, that looks like that. 2 out of 3 pieces. Another way we could use fraction strips, use 6 1/6 parts, so 1 whole split into 6 equal pieces. Looks like that. Still 1 whole, just cut up now. How many 1/6 size parts should you cross out to model the slices that Sam ate? Well, he ate, we should have filled this out up here, whoopsie. He ate 2/6 of it, so I'm going to cross off 2 of those unit 1/6. 1, 2. So we crossed out 2 of those, 2 of those sixths. How many 1/6 parts are left? There are 1, 2, 3, 4, 6 left. So what is the difference? We have 1 subtract 2, 6 is equal to 4, 6. I always rewrite if I'm dealing with fractions, I rewrite a solid 1 as the denominator I need, 6/6, to get 4, 6. And of course, reduced. 4, 6 is 2/3. I didn't fill this out. How much pizza did Sam begin with? 1 whole pizza. How many slices are in a whole? 6. How many slices did Sam eat? 2 out of the 6. This question says, explain how the equation 6/6 minus 2/6 equals 4/6 is related to the problem situation where we just had the 1. Well, 1 and 6/6 is the same number. It's just that this 1 whole pizza has been now cut up into 6 pieces. So I think I'm going to put it that way. 1 whole pizza is 6/6. 1 whole pizza is the same as 6/6. It's just saying I took that 1 pizza that was not cut up, cut it into 6 equal pieces, but still sitting there is 6 of those 6 pieces. That's the whole thing. So they're the same amount. It's just cut now. Sam ate 2/3 of the pizza and put the rest away for later. Explain how you can use the circle to find how much of the pizza Sam put away for later. Okay, I would use, let's say I'm going to do the circle on that. We had 1 whole pizza and he ate 2/3 of it, right? So this time I'm not going to cut this into 6 equal pieces because this one's over here is cut, that I'm comparing it to is cut into thirds, into 3 equal pieces. So instead I'm going to cut this into 3 equal pieces. And I still have 3/3 there, so I'm going to put 3/3 minus 2/3. This is the same equation or the same calculation as this one. I just now have cut this pizza up 3/3. And I cut it into the amount of pieces I wanted, so that my calculation is easy. He ate 2/3 of it. There's 1/3, there's 2/3, so he has 1/3 left. Or if I calculate, 3 minus 2 is 1/3. Let's look at this Sharon Show and see how we do. Lisa needs 4/5 pound of shrimp to make shrimp salad. So not a full pound, but almost. If she splits that into 5 equal pieces, she gets 4 out of the 5 pieces, just shy of a pound. She has 1/5 pound of shrimp. How much more shrimp does Lisa need to make the salad? So she needs 4/5. She has 1/5, so she just needs a little more to get there. We would subtract 4/5, or we'd take 4/5, the amount we need, and take the 1/5 we already have away from it to know how much is still needed. We can shade this model here. Remember 5/5, 5 over 5, it's split into 5 pieces. I have 5 equal pieces. That's 1. That's 1 whole pound. And so we're looking for numbers that are between 0 and 1, but not a whole amount, these in-betweeners. She needs 4/5 of a pound. She does not need a whole pound. She needs 4/5 of a pound. But she already has 1/5. So I've shaded that in. So how much more does she need to get the 4/5 that she needs? She needs 1, 2, 3/5. 3/5 of a pound. So 4/5 minus 1/5 equals 3/5. Lisa needs 3/5 more, a pound more shrimp. Let's look at this one. This is 3/6 minus 2/6. Here's a model. This is 1 full. split into 6 equal pieces. There's my 3, 6 shaded in, and I want to take off 2 of those 6, so those are being taken off, and what am I left with? 1, 6 is what I'm left with. 3 minus 2 is 1, 1, 6. If it were a pie, and I had 6 equal pieces, or a pizza, which is even better, 6 equal pieces, and there were 3 6 of that pie there, and then you took 2 6 of those away from me, I'd be left with 1 6. Okay, here is 8 tenths minus 3 tenths. Here it is modeled for us. 1 whole is that, but that a same amount split into 10 equal pieces is 10 tenths. We only have 8 of those 10, so that's what's purple. And we're taking 3 of those tenths away. So how many tenths am I left with? 1, 2, 3, 4, 5 tenths. 5 tenths. If I was doing pizza, and I cut it into 10 equal pieces, pretend those are 10 equal pieces, I did my best. And I had 8 tenths of them to start with, 3, 4, 5, 6, 7, 8 tenths. That's what the amount of pizza I had to start with. And you came along and you ate 3 of those tenths. You ate that one, and that one, those 3 tenths. What am I left with? 1, 2, 3, 4, 5 tenths. So there's it modeled as a bar, there it is modeled as a pizza, and there it is calculated. And pretty soon, once your brain adapts, and maybe already, you won't need the models anymore, and you can just calculate it. You check for those common denominators. If they're already common denominators, you're in good shape. You can just do the subtraction up here. I am going to continue modeling it for you in case your brain still needs that, but we'll do the calculation first. Denominator is still the same. These are cut into 8 equal pieces, so it's going to stay 8 equal pieces. I had 5 of them. You took 2 of them, so now I only have 3 left. 5 minus 2 is 3. Here it is modeled as a pizza. The pizza cut into 8 equal pieces because that's our denominator. I started with 5 of those 8. 1, 2, 3, 4, 5 there, and then you came along and ate 2 of them. Taking those away from me, I'll change the color so that's more visual, and I am left with 1, 2, 3 8s. Here we have 7 12s minus 2 12s. I have pizzas that are cut into 12 equal pieces. I started with 7, you ate 2, so now I'm left with 5 out of the 12. Here it is as a visual. I started with 7 12s. This is a pizza cut into 12 equal pieces, and I started with 7, 1, 2, 3, 4, 5, 6, 7. You came along and ate 2 of those. 2 of those, and I'm left with 1, 2, 3, 4, 5 of those 12. And finally, we have a pizza cut into 4s. Ooh, that's nice because I don't have to share with so many people. I started with 3 out of the 4. You ate 2 out of the 4. So out of the 4, how much do I still have left? 3 minus 2 is 1. I have 1/4 left. Visually, that looks like this. There is a pizza cut into 4 equal pieces. I started with 3 out of those 4 equal pieces. There's 1, 2, 3 of them. And then you came along and you ate 2 of those 4, and I was only left with that 1/4. So this lesson is really about, yes, getting used to the calculation, but letting your brain understand what's happening in these, because if you understand what's happening in these as you work with word problems later or real scenarios later, your brain can envision what's happening. It understands what's happening. I think you're ready to go ahead and go on Think Central. I think you've got this.